effectively on an oil and gas installation. And the maturity level reflects the progression of that through the project life cycle, each individual component. And there are rules and standards for this maturity. So you can't have one discipline, the instruments discipline, say, calling it one thing, and a piping discipline calling it another. You need to bring these standards together. And also you need to bring each project into the same thing. The technique has a long history, by the way. We first developed this technique in 1996, prototyped it, and ever since then, in the last 15 years, we've been evolving this over and over again and steadily improving it. There's still a lot of potential to be mined from this technique, by the way. So just to set the scene, it's all about the delivery of technical integrity. We need to have an information set that's delivered to operations that is the same as the actual physical plant that we're delivering to operations. If you don't do that, you have a big problem on your hands with technical integrity, and it's a very important issue for BP. You need to know where everything is. Every document, every tag is stored. And it's stored in this thing called the central information store, which I'll expand upon in the next slide. And you need to know the status of everything. It's very important because that helps you make decisions. The objective is to improve our productivity, less wasted time trying to find stuff, less wasted time working on immature stuff, less wasted time working on stuff that's mature, that didn't need to be worked on. We want to use this information to help us determine progress, overall progress. Progress the components, you progress the activity, you progress the overall project. And therefore we use this as a basis for KPIs. And we want to use this information to make project decisions. Things like, well, when do I decide to start manufacturing these 100 valves? And we use it to drive information handover. At the end of the project, you're handing the physical plant over incrementally as the things are commissioned. You're also handling the information over that's in support of that activity. Success story one comes from the ETAP project, which is a very large oil and gas project in the middle of the North Sea in 1996. On it, I was working for a contractor at the time, not for BP. We prototyped many new project management techniques, hand in glove with BP. And we broke new ground in information management. It's a real pioneering project in this area, where we discovered that the techniques we used in normal 3D CAD model management were equally applicable to wider techniques in project management, likewise document management. This is kind of bringing all this stuff together. We proved that information management actually does help to improve the quality of the project deliverable and the time and the costs. We can actually improve all those three things if you use techniques like the one I'm about to describe. And there are some examples of that. We used it to focus the delivery of piping isometrics for construction. And other documents. We use it to focus the delivery of service supports, pipe supports, very boring things, awful lot of them, and they're right on the project critical path. And we're trying to really improve that performance, which actually overall improves the performance of the project. Things like the management of cables as well, and holes in walls, they're a very big challenge. And also the expediting and use of it to get supplier documents out. We have a very large supplier network which we have to deal with on our major projects. So what's changed 15 years on? Well, we'll just unpack that. And basically what it is, it's all about bringing this prototype technique that we developed on one project and making it standard as part of the overall portfolio of BP project execution methods. It's all about information-centered working. What you need to do is you focus on the management of the information, which then helps you manage the project as you radiating outwards from that. What is information? Well, for this purpose, it's all about the delivery and management of documents, information about tagged items, we call that data, and the models, the 3D CAD model, for instance, the simulation of the plant in process, you know, how the process plant works, the simulation of the structural performance of the model. And there's an awful lot of stuff here, as I said, 100,000 tags, 50,000 documents, that kind of number. It's a big challenge. Terabytes of information get moved around the world. What we're trying to do is get this central information store. The idea is you store all that stuff in one place, and one place only. And that means you know where it is, because if you store it in multitudes of places, you won't know where anything is. You might have a good guess, but you'll never know exactly where it is. And we're trying to get this concept of the central information store from endured by the engineers, they don't like it, to trusted, to accepted. And in fact, we're moving very fast along that thing. People no longer endure this thing. They recognize it's part of the project portfolio. So a theme of endured is information is an afterthought. I'm doing the real job and then I've got to do the information. That never works. You always get quality problems and you never get good performance out of that. To accept it, I can see how this technique we're using might help. To trust it, I'm using this technique and it is really improving my performance. We're trying to get people to think that. And the golden rule is if it's not in the central information store, it doesn't exist. You've got to implement that. And then the next thing is, once it's in that central information store, you need to know the status of that component, where it is, how mature it is. Direct benefits, well, it enables informed decision making. If you know the status of something, you can make a decision about it. And you can use it as the sound basis for progress measurement. If you know the status of all your components, you can use that to roll up to help calculate progress. You can't do the whole thing using maturity management. And you can make decisions about individual lines. And I talked about piping lines and pipe supports. Can I now support that piping line? Is it mature enough? Or is it going to move about the design? And then you can group these together onto a P&ID. I don't know if you're familiar, they're a very important document in the process industry. You can group them into purchase orders, all the valves on a project. You can group those and you need to place a purchase order with a certain vendor. Or you can do it to help you drive commissioning and handover. And you can use the associations. You know that lines are connected to pumps. How are they connected? Which pump is connected to which line? Valves are parts of piping lines. Cables have froms and tos and all that kind of thing. You use those associations to understand how these things are all connected so you can then understand the status. And we use this to drive information handover. Handover is all about giving the equipment to the operational group, but at the same time you give the information to the operational group and they have to accept it, and you need to know at a component level whether they've accepted things. You group them into batches, but you generally drive this thing at component level. And you can help this to make project comparisons. In other words, how's this project comparing with how that project? They should be the same. Why are they different? And you can use this to help drive change management. You can firstly use it to help decide whether this thing requires change management. Is it mature enough? Have you shared it with somebody? If you've shared it with somebody, you've got to tell them about the change. And you can also use it to progress changes through a project. It's quite a powerful technique in that area.